What is the three-filter experiment? Well, it's a way that you can show quantum behavior in photons in your garage. This up here is a diagram of what happens when you shine light through a polarization filter. You have unpolarized light, which is this superposition of going every which way. It interacts with the polarization filter, and then you get light which is only moving in one direction, in this case horizontally. So what happens when you put one vertical filter and one horizontal filter, one after another? Well, you get no light. You get this black spot. The first filter filters out all light that isn't moving vertically, and the second filter filters out all light that isn't moving horizontally. So since the first filter leaves us with only vertically moving light, that means no light gets through the second filter. Unless you put a third filter in the middle at a 45-degree angle. As you can see over here, where there are only two filters, there's just this big black spot. But adding an additional filter at 45 degrees somehow lets more light through. How does that make any sense? Now, before I continue, I just want to let you know this is a vast simplification that avoids a lot of the complex math. Physicists who want to point out the more complex stuff, feel free to make a video, but don't come at me. So you may already know that quantum objects have a sort of probability to them. We can express the way a photon is moving, the wavelength of a photon, in terms of that probability. Over here, the photon just kind of has equal probabilities of being in any direction. Over here, the photon has 100% probability of being horizontal. Vertical light is 100% vertical and 0% horizontal. Horizontal light, 100% horizontal, 0% vertical. So what is 45-degree angle light? Well, a 45-degree vector this way can be represented as a combination of other directions, specifically 50% this way and 50% this way. And so when you have a vertical filter and then a 45-degree angle filter, since this 45-degree angle is about 50% vertical, about 50% of the photons are going to get through the 45-degree angle filter. And then if you rotate the whole thing, you can make the 45-degree angle one vertical and the horizontal one 45 degrees. And you have the same situation. You have this filter at 45 degrees being 50% this filter, that's vertical. So again, about 50% of the photons are going to get through the last filter, meaning that here, about a fourth of the photons get through. In this example, you have light which is 100% vertical trying to get through a filter which is 100% horizontal. That leaves you with a 0% chance of getting through. But in this example, you have light that's 100% through, getting through a filter that will let it through 50% of the time, but also kind of adjust it to be filtered this way. And now that you're getting this direction light coming through that filter, it has a chance of getting through the horizontal filter because it has a horizontal element to it. It's a weird example where adding more filters lets more light through, and that's because of the quantum nature of photons.